who uses serverless here? A couple of people. Who's heard of serverless? All right, great. Who's heard of Zeebe? Come on. OK, great. Well, I played around with serverless functions this year. It all started in February, so I built some serverless functions. So I had 1 and 2 and 3, and then thought about it. How do I connect them? It's also about orchestration. So I played around a bit, and I had a vision. I knew how to connect them. But I also wanted to know how others would do it. So I did a little experiment. I printed out this slide that you're seeing in a paper and distributed it among some colleagues. And it describes a small workflow, like send a letter to a customer, and if the customer number is odd or even number, you contact the customer or not. And the task was pretty simple. The participants would describe the workflow in a notation of their choice. So it could be a visual notation, a function, or JSON, or XML. So these are the results. I was a little disappointed because I thought everyone would use a visual notation. But we had a doctor, as a guy who has a PhD in physics, and who chose to build a function. That's cool. And I also gave the same task to my wife, and she came up with this. I'm very proud of that. It's very cool. So this is just a small scope which shows that people like to describe their workflows in a visual notation. Why I did that, I'll explain in a couple of minutes. So I've been developing software since 12 years, and I consider myself a techie. And I've been working for banks and public government agencies, and at the moment for an automobile industry. And where we work, we develop custom software for our customers. And at the core, we always ask the question, why? And at this point, I will ask, why serverless? It's a big topic, but maybe you heard about the saying. The essence is, well, in serverless, there are also servers, but you don't want to care about them. So who cares about servers? I just want a function in the case of a serverless function. So I want a function which scales. I want monitoring out of the box. I want to pay for usage. And so serverless is also growing fast. So that's some statistics from the Survey State of the Cloud report from Brightscale. So they have a lot of statistics and graphs like this. This only shows the usage. And 2018, the usage rate of serverless was 24%, and they asked thousands of IT developers and architects. And this year, it grew up to 36. So compared to other cloud technologies, that's a growth rate of 50% and one of the fastest growing paradigms in the cloud-related technologies. It's also not new. There are a lot of frameworks and platforms and ways to build serverless functions. And what I will show today in Fn Project is just this teeny tiny bit here. And there will be live demos, so feel free to get excited, because it can crash and not work, so we'll see. There are also a lot of ways to orchestrate serverless functions. So AWS has their own way, and all frameworks come up with some solution. That's one way to do it. That's the Oracle way, FN Flow. Well, the developers thought, OK, well, the developers are using a programming language to develop the function, so why not use the same language to develop the flows and connect them? And it's cool, but I don't want it. I like it the visual way, and that's why I did this small experiment to find out if I was the only one who doesn't want to program workflows. So You can see here on the left side, that's the AWS way, a step function, so you can visually connect lambdas. And Netflix Conductor has a JSON-based notation so that you can define your workflows. And in ING Baker, and there are a lot of frameworks, so they all have different notations. But the thing is, they all have the same concepts. So you have some tasks, you have some retry mechanisms, and you have compensation and timers. So that all sound like BPMN. So why not use BPMN instead of learning a specific notation? Well, that's why, because BPMN is slow. At least I think there are a lot of people who are thinking that BPMN is slow because you have a relational database underneath. Maybe you have some JBoss or WebSphere, web server, application server underneath it. Well, I think nowadays the modern BPM engines, including Camunda BPM, look like this. Oh, I spoiled the next slide. So they're fast, and I wanted to know how fast, and I looked up some numbers, and I found a slide from Camunda from 2015, and they stated using Camunda BPM engine, they can process 1 million process instances in a day without any problems, and thousands of instances within a second without problems, and also thousands of parallel usages. So that's pretty cool, and I think it is now a bit faster. Just my assumption. But do you know how many process instances you will use in 3 years? Or 5 years? Or at Christmas? Or when you just kick on your new product? So scalability is an issue here because relational databases don't scale that well. So we heard of Zeebe, and well, it is aimed to solve that problem. Because not only now you have a fast engine, but you can now scale it. And so those are show planes, I guess. They are doing a choreography or something, and you can see those red lines, which are, I don't know, some paint for show purposes. Well, I thought of that, oh, they have a defect, maybe. So maybe they have the land. No problem, you still have 5 or 6. And if you need more, you can just add them up. And Zeebe allows that. And the cool thing is, this background, the white things, is made for the cloud. The cloud. So welcome, Zeebe. And well, you heard about that in the keynote. So it's the new workflow orchestration engine made by Camunda. And it's open source. And it also it is low latency because it also embraces gRPC instead of HTTP calls. So if you use a native client, you can process your processes faster. And without further ado, I just want to do a live demo. Some of them we saw it in Daniel's presentation yesterday. So, okay. I'll start with operate. So this is a dashboard for Zeebe. It looks like Camunda Cockpit, a bit simpler, and I already deployed a workflow to my local machine. So although Zeebe is made for the cloud, I registered for the beta phase, but I didn't get an account. So this demo is not running on somebody else's computer, but here. So I'm using Docker Compose for that. So those lines that are floating. So I have Zeebe running here, and Fn server, and Elasticsearch, and all other stuff in my machine using Docker Compose. So in Operate, you can see this workflow that I deployed, and I developed it in Zeebe Modeler, which is kind of the Camunda modeler, but I think it's like adjusted so that you don't have the types that Zeebe doesn't support yet. So I will now start some instances using the CLI. Can you read that? It's okay? Yeah? Okay. So I'll using the CLI, and we saw that yesterday, if you were in the keynote, you can create an instance with create instance, and now we have to give the process name. In this case, it's customer contact. And this should start a new instance. I'll also start another instance, as in yesterday. And let's see, I'll refresh that. So we see one instance and two. All right, so let's dive into that process instance. And you can see on the left side all steps that were executed. And if you click on more, you can see some details like the job type, read rise, start date, and the end date, which is open. So these jobs are now waiting to be processed. And at this point, I want to explain the pull principle. I think 2015, Bernd Drucker had written an article called From Push to Pull, and described what external tasks are and how to use them and why to use them. Well, it increases stability and reduces the temporal dependencies. So if you start a job, well, the workers don't have to be there at the same instance, so they can pull the jobs and process them. And Zeebe embraces this concept. So it is by design pull only. So if you look at the Zeebe modeler and click on a task, you don't see any service or delegate expressions. So Zeebe, per default, doesn't know who will process these jobs. So therefore, these jobs will wait until I deploy my serverless functions. So let's go back to the presentation, and let me introduce Fn Project. So the Fn Project is a function as a service platform made by Oracle. And it's an open source product which is installable on premise. So that's the server is running on my machine. And the strategy or the idea is somewhere similar to Zeebe and Camunda Cloud. So Oracle, Camunda introduced Zeebe as a tool which is made for the cloud, but you can run it on your machine, and it's open source. And Camunda Cloud is driven by Zeebe. And the same thing applies here. So Oracle wanted a managed function as a service platform, so that you can start your functions in a managed way in the cloud. For that, they introduced the Fn Project, which is an open source installable function as a service platform. And they are still working on Oracle Functions, so that's the managed function as a service platform of Oracle. It's Oracle Functions. And it is in limited availability right now, and it's planned to be released 2019. This year, I don't know when. It's based on Docker, so if you create and deploy functions, the platform builds Docker images for your functions. And it is language agnostic. And Oracle supports, per default, Java, Go, Ruby, Python, JavaScript, and C#. For all other languages, there are community extensions. So that's the architecture. We have a load balancer, which is kind of a gateway, so that you can call the functions using an API. And then you have some Fn servers, which are runners, which will start your functions on the fly. And if you are operating this on premise, so you would scale by adding servers, or scale down by removing them. And it's also pretty modular, and they have some pluggable databases, queues, and log aggregation stores. So you don't have to use Oracle database. So just a disclaimer. Okay, so let's see how this works. And of course, I will use the CLI because it's cool. So Fn uses apps, which are just group of functions. So to deploy functions, we need an app, and this is just created by Fn create app. So that's it. Now I have an app, and I can create functions, and that's I'll use the init function or the init command. And now you can define the runtime, and I'll go with Go. Yes, pun intended. And the runtime is the language, and then the name of the function is, follows. So this creates a function in a directory called hello-go. And now we can see 3 files which are generated. I'll ignore the Go package toml, that's just a Go configuration file. The function Go is the actual function, and func.yaml is a description which contains some properties. Let's see how this looks like. So it's pretty simple. You have the name of the function, the version of the function, the runtime, and the entry point shows where to start the function. If you are familiar with Cloud Foundry or a platform like this is like a manifest, so the platform knows what to do with the function. So the func.go is the function definition. And it always generates an example function so that you can quickly start to edit it. And here on the upper side, you see some package imports from the Go language. So it's in the language itself. The only thing that is additionally imported is the FDK from the Fn project. That stands for Function Development Kit. And every language that the Fn project supports comes with a Function Development Kit. So it's kind of this support for the language. And in the main method is the only place where this FTK is used. So it registers the function as a handler, and everything else is standard Go. So what this function does is pretty simple. It expects a JSON and reads the name of the JSON and prints hello name or hello world. So to invoke the function first, I'll have to deploy it because init only generates that locally on my machine. And now I have the app demo, so I'll deploy it like with the command deploy app demo, and I'll use the flag local so that Fn function knows that I'm deploying the created Docker file locally on my machine. Otherwise, you would have to use a Docker registry. So it's deployed, and I can call it. There's a command for that. This was in Fn invoke and app name and function name. And it says message hello world, so that's the JSON that the function created. So of course, Fn invoke is only meaningful for testing. If you're in a real world scenario, you would use kind of a trigger to invoke the function. And for this case, the Fn project supports triggers. And at this moment, only HTTP triggers. So I'll create another function with a trigger. Let's create a Python function. Python. And this time, I'll use trigger, HTTP. That's a flag so that the configuration for the trigger is generated. And then the name of the function, hello Py. So now we have a new directory, hello Py, and you see the same, more or less the same files. And let's look at the func YAML file. And it looks more or less the same, with the difference that now we have a triggers section, and the source part of the trigger is the path or the segment under which I can call the function. So I'll just deploy that as well. Deploy app demo hello, no, local. So it's now creating another Docker image. Deployed the Docker image, and now you can see it also printed out the trigger. So I'll just copy that. So now I can call this using a browser, or I can also use curl and do a post request, and I'll just give a JSON to find out it works like as expected. Name CamundaCon, and it prints hello message CamundaCon. So that's a couple of commands to create a function and to deploy and run. And if that was on the cloud, it would be even more cooler. But it's pretty quick to play around with functions. So let's go back, because now the interesting part starts. So now we have the Zeebe processes, or the workflow in Zeebe, and we have the jobs, and we have our functions, and the idea is pretty simple. I want to say, hey, this function should process the job type at the first job type, and the second function should process the second job type. Now, the integration is also simple, but there is a problem. If you are familiar with architecture diagrams, you would know that those round things are provided interfaces. So Zeebe provides interfaces for the job types so that some clients can process the jobs, and the FN project functions are waiting to be called. So we need some glue. And in Zeebe, that will be workers that you integrate in your microservices so that the microservice can pull and process the jobs. In case of serverless function, that's not really possible because serverless functions are supposed to be quick. So you just run a function and it runs and terminates. So you can't put the worker in the function itself. So that's because of that, I implemented a prototype, a proof of concept, to integrate both. That's an FN extension that I built. So it starts with the FN server and looks if a function is configured so that it handles a Zeebe job. If it's the case, it looks for the Zeebe jobs, and when they become available, it will pull the job, read the parameters, the process variables. It would pass the process variables as an input to the HTTP API, and then look at the HTTP response. If there's a success response like 200, it will mark the job as complete. If an error occurs like 400 or 500, it will mark the job type, a job as failed. So let's see how this works. So I already prepared some functions to show that case. First, let's go into the get customer consent. So there's a Python function. It doesn't do much. It just looks at the process variables, looks at the customer number, and if it is an odd number, it would respond with notification permitted, true, otherwise with false. So that's all that the function is doing. And to configure the function, I'll be using just this part that you see, config Zeebe job type. That just says this function will process the get customer consent job type, and which is this type here. So that's all I will do to configure that. So let's deploy that function. Oh, I'll create another app because it's fun. So deploy app customer local. So remember the first task that I deployed, the first instances. So they are still waiting. And now I deploy the function, and let's see what happens here in the dashboard. I'll go back to the filter. And you can see on the right side here, the both tasks are now processed and completed because the process instance didn't have any variables. So the function that I deployed just returned notification permitted false. And here there's a gateway which just checks if we are allowed to contact the customer. So I'll start another process instance. For that case, I also prepared a script, create instance. This just starts the CLI and just adds a process variable, customer number 1, so that it would go to the upper path. So let's create that one. So let's see if you can see the new process. Fresh. Yeah. So the process instance went through the function. It returned notification permitted true. If you go inside, you can see the customer number 1. That's what I gave as an input. Notification is permitted, and now we are waiting to handle the next jobs. So that gateway is a parallel gateway, and therefore they are just running on parallel now. So let's go back. I'll deploy the other function that I prepared. That is the send email function, and I'll deploy that as well. I also configured it. So if you have a look at func YAML, you can see it is configured so that it handles the send email job. Deploy app customer local. Again, this creates a Docker image, and the plugin will kick in and process this job here. So if I refresh in a couple of seconds, you will see an incident, and that is on purpose. Really, is on purpose. Because I implemented the function so that it looks for an email, because it sends an email. And if the process variables don't have an email, it will result in an incident. And I wanted to show the dashboard, and because I like the dashboard very much, it is designed in a simplistic way, so that you can only you see the information that you must see, which are in this case the running instances and the incidents. So on the left side, you will see all process definitions, and they are grouped so that you will see which instances have incidents, which processes have incidents. And on the right side, you see all incidents directly without having to click on your workflows and to search or type in search queries to find out your incidents. So let's click on that one. And you can also see if you open that one, why that's the case. So it says email not sent, not set. So now we can use operate to add a new variable. I'll add an email. Hello. There's no syntax validation, so I'll just not use a real email address. Yeah, you can also edit existing parameters and now retry. This sets the retry counter up so that the workers can kick in again and process this one. So that's it. It's now processed and completed. That's all for the demo. So just one more thing. I like really the design of the pull principle. And as I said, there was this article called From Push to Pull by Bernd. And now, for some services, we have to change back to push. So it's like from push to pull to push. Well, the pull is perfect. It is fast. It allows scalability and other things. And well, and if you have control of your microservices, you can put your clients and workers there and be very fast. But there will be some services out there. They're waiting to be called. Or you just implement some serverless functions. So they are out there and waiting to be called. And for this case, we have to push again. But this proof of concept shows that it can be made easy. So you don't have to worry about implementing all the workers by yourself. And what I learned from Josh yesterday, Camunda Cloud already integrated a kind of mechanism just to call REST APIs within the Camunda Cloud. So don't worry about the workers. I hope that was interesting for you. Thank you.